Hello, mathematicians. This is your video lesson on the midsegment of a triangle. And by the time this video lesson is done, you should be able to find measurements in triangles using the properties of midsegments and using the midsegment theorem. Perhaps you were given a copy of these notes by your teacher to take notes on as you watch the video. If you were given a copy, please make sure you have them handy and something to write with before you continue watching the video. If you weren't given a copy, maybe you can print a copy. And if you cannot print a copy either and you don't have a copy, you can always take notes on a piece of plain white paper, remembering to draw the diagrams that are necessary to draw. Please refer to these notes as you do your homework, very important. And you can stop and rewatch any part of the video if you need to slow it down or go back and see something you didn't catch the first time. And if you're still having questions, you can contact your teacher, and I'm sure your teacher will help you. So we're going to start by writing the definition of a midsegment here and marking this diagram up before we write the midsegment theorem. So a midsegment, let's copy down the definition, is a segment connecting the midpoints of two sides of a triangle. Also in your notes, I saw that point D, the letter D, got cut off, so please label this vertex of the triangle as point D. And let's mark up the diagram. Well, let's mark C as the midpoint of segment BD by putting two tick marks, one tick mark on CD and one tick mark on BC, and that would indicate that C is the midpoint of BD. And let's also mark with two tick marks that AE is congruent to DE, meaning that E is the midpoint of this side of the triangle. That would mean the segment that connects those two midpoints, E and C are both midpoints on two sides of the triangle, EC is a midsegment because it is a segment that connects the midpoints of two sides of a triangle. Next, let's write down the midsegment theorem. So the midsegment theorem states that a midsegment of a triangle is parallel to the third side, so these two are parallel, and the length of that midsegment is exactly half the length of the third side to which it's parallel. So let's mark these two segments as being parallel to one another. And let's mark it that this segment EC is half the length of X if the length of segment AB is X. So what does that mean? That means that if AB is 20, then EC will be half of 20, or 10. And it also means that if AB were 7 meters, then EC would be half of 7 meters, or 3.5 meters. It also works going the other way. If we're told that EC is 20, I know that this is half of this segment. So that means that AB will be 40, twice the length. So AB will be twice as long as EC. And if EC is 5 1/4 centimeters, then to find the length of AB, I just double or multiply by 2 the length of 5 1/4, which will give me 10 2/4 or 10 1/2 centimeters. So now let's use the midsegment theorem and the definition of a midsegment to do example 1. In example 1, we're told that DE is the midsegment of this triangle ABC. So based on the definition of a midsegment, which means that it goes from midpoint to midpoint, E must be the midpoint of AB and D must be the midpoint of AC. So I'm going to have you mark that these two pieces are congruent, and with two tick marks that these two pieces are congruent also. Well, if E is the midpoint of AB and these two segments are congruent, then X must equal 5 because EB has a length of 5, so AE also has a length of 5. And if DC is equal to 8, well, AD is congruent to it because D is the midpoint of AC, so Z must equal 8. Next, to find the length Y, I'm told that this is the midsegment, but based on the midsegment theorem, this is going to be half the length of BC. So DE is half the length of CB. So that means that 6 is half the length of BC. So 6 is half of what number? 6 is half of 12. Just take 6 and multiply it by 2. So this is going to be twice as long as the midsegment. To find which two segments are parallel, I know that the midsegment will be parallel to the third side of the triangle to which it's not attached. And since ED is attached to this side and this side, this is the side that it must be parallel to. So ED or DE is parallel to side CB. We're also going to use the midsegment theorem to do example 2. So again, we're told that DE is the midsegment. So I know that this is a midpoint, and so is D. E is the midpoint of AB, and D is the midpoint of AC. So if E is the midpoint of AB, then these two segments are congruent, EB and AE. So X must equal 5. And if this is a midsegment, then that means that D is a midpoint of segment AC. So AD must be congruent to CD, meaning that Z equals 6. And this time I was given the length of the side of the triangle, not the length of the midsegment. So to go from the side of the triangle to the midsegment, I'm going to just take half of that length, 8. So half of 8 will give us 4, so y is equal to 4. And again, which two segments are parallel? Segment ED and the side of the triangle to which it is not attached, CB. We're again going to use the midsegment theorem to do example 3. In part A, we're told that IJ is the midsegment or one of the midsegments on triangle HKL. By definition of a midsegment, I know that J is a midpoint of this side and I is the midpoint of this side because a midsegment goes from midpoint to midpoint. So I'm going to mark HJ congruent to KJ, and I'm also going to mark with a different number of tick marks side HI congruent to side LI. In part B of example 3, we are only going to find the value of X. We solve for Y in part D of this example, and this is a typo. There is no Z in this example, so you can just cross that off. First of all, let me state that the incorrect way to set this up would be to say that x plus 5 equals 3x plus 3, and that is incorrect because this measure is not equal to this measure. So be careful about the way you set up your equations. To solve for x, I'm going to set up an equation one of two ways. I can either say that ij equals half the length of KL, or I can set it up so that I double the length of ij and then set that equal to the length of KL. If I do it this way, I have this equation. X plus 5 equals 1/2 of this length, 3x plus 3. If I do it this way, I have 2 times this length, x plus 5, is equal to this length, 3x plus 3. I personally think this way is easier because it doesn't have any fractions in it, but you can do it any way. Either way will get you the right answer. When you do your homework problems, you do not have to do both ways. You can choose one. I'm going to solve this equation first by distributing the 1/2 to 3x and 3. And I end up with 1/2 of 3x is 3/2 of x, and 1/2 of 3 is 3/2. Since this has fractions, I'm going to clear the fractions by multiplying the entire equation by the common denominator, 2. There's other ways to do it, but I think it's easier to clear the fractions. That will give me 2x plus 10 on this side, and on this side, this multiple of 2 will cancel out the denominator of 2, so I'm just left with 3x. And likewise, 2 cancels out this denominator, and I'm just left with the whole number 3. To solve this equation, I start by subtracting 2x from each side, and I end up with 10 equals x plus 3. Next, I subtract 3 from each side to get that x equals 7. if I solve the equation set up this way, I'll end up with the same equation. See, 2x plus 10 equals 3x plus 3, the same exact equation, and I would solve it the same exact way and still end up with x equals 7. So now to find ji and kl, I'm just going to substitute the value of 7 in for x. So ij will equal 7 plus 5, which will give me 12. And the length of KL will be 3 times 7 plus 3, which will be 21 plus 3, which is 24. And that makes sense in context because we know that the length of the midsegment should be half the length of the side of the triangle to which it's parallel. So this does make sense. For part C, I'm asked to find the length of HJ if HK equals 14. I'm going to go ahead and have you mark your diagram that the length from H to K is 14. And this is pretty easy because I know that J is the midpoint of HK. That means that I'm going to get the length of HJ, I'm going to just take half of 14, which will give me 7. Now let's go on to part D. We're told that HI from here to here is equal to 5y minus 2, and IL is equal to 3y plus 4. And then we have to find the length of HL. So I'm going to go ahead and mark the diagram. We already have the tick marks there, but I'm going to write in the lengths 3y plus 4 for IL and 5y minus 2 for HI. And in this case, it is appropriate to set these two variable expressions equal to one another. And that's true for this case because I is the midpoint, so this length, 3y plus 4, does equal this length, 5y minus 2. So I'll set up the equation as 5y minus 2 equals 3y plus 4. And to solve this equation, I'm going to start by subtracting 3y from each side, and that will give me 2y minus 2 equals 4. And then add 2 to both sides to get 2y equals 6, and then divide each side by 2 to undo multiplication by 2, and I get that y equals 3. So if y equals 3, then I know I'm going to have to find HL by first finding one of these two lengths. I'm going to find the length from H to I. The length from H to I is 5y minus 2, so that's 5 times 3 minus 2 because y is 3. And that will give me 15 minus 2, which is 13. So that means that the length from H to L must be twice the length of HI because this is the midpoint. So that'll give me that the length from H to L is 26. And I always like to double check my work before I go on. So let's just make sure that when I plug in 3 for this length that I also get 13. And if y equals 3, then the length from IL is going to be 3 times 3 plus 4, which is 9 plus 4, which is 13. So yes, that does check out. It's important to mention that every triangle can have 3 midsegments drawn inside of it. That's because we can take the midpoint of each one of the 3 sides. These 2 segments would be parallel, these 2 segments would be parallel, and these 2 segments would also be parallel. We also know that this midsegment is half the length of the side to which it's parallel. But M is a midpoint of CD, so that means that CM is also half the length of CD. And DM is half the length of CD, so these 3 segments are all congruent. Likewise, these 3 segments would also be congruent, and so would these 3 segments. So to conclude, we know that the definition of a midsegment is a segment that connects a midpoint to a midpoint of 2 sides of a triangle. And we also know that that midsegment is parallel to the 3rd side, and that it is half the length of the side to which it's parallel. And likewise, this segment will be twice as long as the midsegment to which it's parallel. So that concludes our lesson on midsegments.